Okay. Okay, everybody ready?
Yep.
Ready or not? Here we go. Okay. So, here we go. Okay, so we said 14. Uh, okay. Class 14. Okay. Factory pattern. Uh, that's chapter 4. We already went through a lot of this. We went through functional. Uh, you know what that is, right? That this chapter 4 discusses functional requirements, which is specific requests by the user. Non-functional, we said, was a general requirement, like speed and stuff like that. These are all non-functional, right? But and the challenge is to be able to 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 quantify it, right? So the column on the right gives you suggestions how to you know how to do that, right? Okay, because it's hard to something that's non-functional like speed, size, ease of use. Like somebody comes up to you and says, "I want a car that's quick." That's very hard to quantify because what does quick mean? Quick to accelerate, quick overall, quick to turn on, or I want a car that's roomy. You know, again, that's very hard to quantify. What does that mean? Roomy where? In the seats, in the storage, right? Or they say I have a lot of storage. What does that mean? What do you want to store? Does it mean things like boxes, or does it mean things like total storage, right? A lot of times you have a lot of storage space, but it's unusable, right? Because if the back of the car is like, you know what I mean. If it's like on a slant, you really can't put too many things there. Even though there might be a lot of space, quote unquote, but it's not really usable space. Okay. So that's something needs to be quantified. Ethnography, we went through about that. Um, then over here we said there's two different types of use case. There's a use case table, which is a very specific thing which tells you basically um, the order, the minute details. So a use case table, it's very specific. So it's supposed to be very specific, right? So it tells you every every single um, you know, every single thing that should happen, right? When there's for example, like this would be an example of a use case table. So it tells you who the people are that use it, what needs to happen, blah blah blah. So it's a very specific, detailed thing. This, on the other hand, is a use case diagram, which only which is a very high level, right? This is something like maybe the the person in charge of a project would have this diagram, right? Let's say the vice president of a company, the vice CEO or whatever, the head of, let's say, the IT department would have this diagram, right? So they would say, have like, what are the activities I want the program to do? Who's going to interact with it? Or it might even be a little bit lower, but it's pretty high level diagram, right? There's no coding, there's no architecture. They're just things that you want the program to do, right? So before you do any program, you would want to, this would be a good way to just to, think about your program, which be what do I want my program to do? Right? Let's say it's a game, right? What do you want your program to do and who should do what, right? Right. So if you have a website, what do you want in this example? What do you want the customer to be able to do? You want them to be able to view items, make purchase, and log in. But then on its own, the program has to also be able to to process the credit card, right? Or whatever, however else you're paying, right? It has to be able to complete the checkout, and it needs these actors to be able to do that. Okay? So that this is basically a more high level way the program is going to be. Before you actually start doing the program, you would make something like this, a very high level way that the of what you want the program to do, right? If you're doing a game, uh, you would have that I think would be very. I'm not sure how you would do a use case diagram because it would have to be like kind of like log in, play game, and finish game. I don't know. I don't know exactly what you would do. Yeah, so, it's something, but it would have to be something like not. It wouldn't be too many activities, right? Because you can't do, level one, level two, level three, level. Maybe you could. You have level three, level four, level five, and six, and then if you reach six, then But again, it's not telling you how the program works. It's just telling you what it does, like the types of activity it does. So it could be that if you wrote a game, like the whole play game would be one oval. You know what I mean? Like log in, play game, and then maybe when you exit the game, um, or something like that, like log in, pay, payment complete, play game, and then maybe that those are only the activities you would show in this diagram, right? You wouldn't want it to make too detailed, right? So it's kind of a high level diagram, right? And maybe if you want to monitor the game, you would have like a actor over here, which is gonna interact and it's gonna make sure the person isn't doing something like let's say this is Facebook, you would have like maybe somebody from Facebook on the right who will be monitoring all the users, checking what they're doing, right? See what they're typing in, make sure they're not doing anything malicious. Here's another example of a use case, but it's without the square. I like the square around it, the box around it. And it's a little more clear. But this is again, this is a um, the activity diagram to buy a ticket, and I guess he doesn't. There's no details. It says checks if there's a ticket available. You pay, you book a ticket, right? Cancel or if you cancel, you refund money. But again, it shouldn't. It's a little bit too detailed, I think, because um, um, I'm not sure exactly. I think that in my mind is already getting too 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 many details. Okay, it just be just general things you do, right? So I would just say check availability, buy ticket, and then um, that would probably be it. That's all I would put in there. I don't think I would. Um, I don't know. To me, it's a little bit too much detail for the activities you do. Okay, that was chapter 14. Let's do 15. Is there a 15? There is no, there is a 15. Okay. And this is basically nothing there. Um, uh, and next 16. Um, what we have in 16. We don't have anything there either. I think this is when we were doing for the projects, we're up to 17, right? 17. Uh, we did oh, yeah, this is the design patterns. No, we already did that. No, that's just a review, I think. So that would be, okay, 18. Well, we're going fast. 18. Um, so we did, oh, yeah, chapter 5. Okay. So, um, it's just a review of the use case diagram. Okay, here's a chapter 5 diagram. This is what's known as a context diagram, which is really high level and really easy to understand. Basically, it's supposed to be snow tomorrow? Yikes, what time is it supposed to be snow? Do you know?
It's actually already snowing right now.
What?
It's already
Really?
snowing right now, yeah. Or it was
Yeah,
whenever
but
I
it's
was earlier.
37 degrees, so.
It should snow
Yeah.
around like 11 or 12. That's what, like,
Uh,
more
Yeah.
heavy.
I
Oh, in
think
the
it's snowing
morning?
now. Yeah. I was just
Oh, here it
outside. It
is.
was, yeah, I was just outside. It's snowing right now.
Oh, really? Okay, thanks. Oh, I'm gonna have to drive somewhere tonight. Okay, I didn't know that. Yeah, but it's gonna melt, so should be okay, right? Yeah, okay. I found that this my thing in the corner, it's always wrong. That's not a surprise it was actually snowing because it's always been wrong. It says getting cold, really, and then it's not so cold, and then I don't know, they're usually wrong. So I don't have that much faith in it. Okay, so this is a context diagram, and basically your program is in the middle, and everybody else all the other programs are around it. Okay, so you're the circle, right? So in this program, the community is my program, and the boxes are some other programs that it interacts with. So for example, here you have an online community who interacts with the community users. So the middle is my program and interacts with these. So this is like something the CEO would know, right? So the CEO would make a presentation. They say, this is our program, the online community. And we interact with community users, advertisers, community manager, and control creators. And this is how we interact with them. So this is like a very high level diagram of what your program will do. Okay? This is already more on the business level, like how the program should work. Like this would be like the business analyst would work on this or look at this. They would tell you again this is where you start, and this is like called the bullseye. This is where you end, and this is a activity slash process diagram. So the goal is to start here, end up here. Ignore these boxes at the bottom. They're just like more like notes, right? So the idea is you start over here, and you make sure that in this case a person should go to hospital. Then you decide. Then you could do two things at once. Then you would stop over here, you'd wait, then you would continue, and then you would go, you would, this is called decision node, and you would have to either go one place or the other, and then you either go to you either decide the person's not dangerous and you go to regular hospital, or you say they're dangerous, then you would have to find a secure place. And then from here, you could either go to transfer to police station, transfer to secure hospital, or the other one. But any of these three, after the person is at one of these three places, we would go to this bar, which is actually a mistake. It shouldn't really be a bar because you don't have to wait for anybody else. Once you get here, you would do whatever. It's a little bit misdrawn. It should really be a diamond and then the bar, and then and then you would be able to do, once you get here, you'd be able to do three things in parallel. You would be able to inform social care, inform next of kin. I'm sorry, you would have to do all three, but you could do it at the same time. So say informing social care takes 2 days, next kin would be 1 day, and update register would be 1 hour, right? So you would just have the most this would take you would be 2 days, right? Because you would have to be able, this is how much, then once all three are finished, then we're done. Okay, that's how you read this diagram. Okay? Again, you could just like, I think I might have even put this in the document. Yeah, here I even explain. What this means like you're waiting for two activities before you continue. Over here means you're going from one activity to two activities that can be done at the same time. Over here it's decision node. This means we reach the end. This means, in this case over here, we make a decision because when you have two arrows leaving a diamond, that means we're making a decision. We're going one way or the other. And then over here, we're we having two activities go into one activity, right? So we're merging this read mail, or this is probably delete mail, and then after that we go into this and we continue with whatever we're doing. Okay? Good? Bad? Questions? Okay, so then over here we have a same process diagram, but it's broken up by objects. So this is what these are all the activities, same diagram as above, but it's broken up what's called swim lanes. And here we have all the activities the author could do, the reviewer could do, the approver could do, and the owner could do. So for example, the owner is only doing one activity. Again, ignore the box. Just look at the oval. Um, okay, so there's a sequence diagram which we went through. And then we do that. And then we have the state diagram, which basically over here there's a double state diagram. We have the engine on and off. And then within the engine on, we have park, drive, neutral, and reverse. Right? Now that modern cars, by the way, don't have this because modern cars, engine could be off while you're parked, right? Engine will go off. I once rented a car like that. It was pretty cool. Like I thought it was broken. I didn't hear the engine. What? It just turns off, when it's not being used. So, um, so that's those are those. And let's go to 19. 19. We have again chapter 5. Maybe we added a few more to the bottom. Let's see. Sequence, state. Oh, no more there. Let's go down to 20. Oh, we're getting pretty fast. 20, which is probably, you guys are probably getting a little bit okay, finally we're up to chapter 6, which is architectural patterns. So just read through this a little bit. It explains the three-tier architecture and explains the in here we went through the ideas behind it. Number one, that when which is the bottom layer? The database layer. Why is that the bottom layer? Because none of the other layer, because it doesn't require any of the other layers. So the application layer requires the database layer, and the presentation layer requires the application layer. But the database layer is at the bottom because it doesn't have any dependency on any other layer, right? And the idea is that when you change a bottom layer, you could break the ones above it. Uh, but this three-tier, it's divided the way it is because of a few reasons. But first of all, it's logical, and also because different types of people do different types of things. So people who know graphics will do the top. People who know databases, which there are people like that, database, they're called database managers, right? DBAs, database, I'm sorry, not manager, administrators, right? So they take care of the database, make sure it's running properly. They take care of the data, backed up and stuff like that. Then you have the application layer, which is most of the code, which is the business logic. Three would be that if you break it up, so then layers, then it's easier to test. So you could test one layer by itself, each layer by itself. Um, and four is once you have things in a layer, then you could swap out one layer for another. For example, instead of writing to a desktop screen, you could maybe write to a web page, right? Theoretically, or to a smartphone or to something like that. Okay, then I spoke about issues specific to web applications. Um, One is security because it's open to the whole world, rely on the web browser for security, rely on the internet. So it's sort of dependent on a lot of other things. Um, Web page is very boring. You need JavaScript to make it interesting. Um, there's an issue of bottlenecks, so you have to worry about that. Then we spoke about these things, performance, security. Uh, and these are the different patterns, architecture patterns. Here's client server, here's pipe filter, peer-to-peer we left out before. Now we're just basically it's one that a for example, your PC could be both a client and a server. So, for example, if you're doing Bitcoin, right, you might be um, getting data from a server from another computer, and you might be sending data, right? You might be mining Bitcoins, which I don't know what that is, and you might be getting data. I don't know I don't know anything about that, but that's the idea. Okay, it's not that common nowadays because people don't, in general, allow their computers to be if you're usually a server, you're not a client, right? You're not gonna, no, clients are not normally servers. Right? Servers are very secure. They have special, you know, things protecting and stuff like that. Usually don't open up your home PC to let someone else look at it. Okay, MVC, we said that's normal. This is a pattern for a web server. So you would get the controller would get the request from the client, the would send to the model on the web server, which would then send back data to be sent to the view, which would send a response back to the web client. So it's just a way of dividing up how the web server works. Okay, that would be 20. And I'm just basically reading the stuff. Oops, we're up to 21. Um, and then we have 21. Where are you, 21? Here we are. 21 again is dealing with architecture patterns, which we just did. Okay. And then 22 deals with probably testing, right? So we spoke about testing. We also went through this. Um, we spoke about this idea of red light, green light, right? Or test and drill, where you write the test before you write the code. We spoke about regression testing. Does everybody remember what that is? What's regression testing? Regression means to what? To go back?
To go back to previous
Right.
existing
So
code,
how would we go back in testing?
we just rerun the previous test that ran before.
In other words, if regression test, make sure that we write a test for a bug that was fixed before because we don't want that bug to come back. Right?
Right.
Right. So we want to, because it's very common for a bug. No, it's bugs usually happen in the same place in the code. It's very common because certain parts of the code is where there's more action. So once we fix a bug, we want to write a test to make sure it doesn't come back because there's a good chance that it might, right? Right. So, sort of like, your car, you know, what are what parts of your car could break? It's usually the same things, right? The tires, you check your tire, like before you go on a long trip, you'll check your oil maybe and your tires, right? Because those are the things that are are going to break, right? So that would be like regression testing because you're just, those are the parts that or if you have something else wrong with your car, that's what you would test because those are the types of things that break, right? Those are common for issues to happen. Um, Actually, not necessarily. Just yeah, I think so. Yeah, you don't check you don't do a diagnostic check of your computers before you go on a long trip because chances are that it's not going to, yeah, that it's very uncommon for something to break there. Though if it does break, it's kind of catastrophic, right? Red light, green light means again you write the test that fails before you write the code that works. Okay? A unit test that fails. Pretty cool. Before we write working code. Okay. This is all before AI. I wonder what this guy Bob Martin will say about AI. It'd be very interesting to see what he would say. I wonder if uh, Bob, Robert Martin with AI. I wonder if um, he actually spoke about it. Oh, wow. I would like to see what he says. Okay. Very interesting guy. Okay. He's still around. Okay. So he's basically the king of the inventor of Robert Martin's the guy who invented basically a lot of object-oriented programming. So a lot of what in this course is based on what his ideas. Okay. We spoke about advantages of unit tests. Basically, tests can automatically run right. We said that they're automatic. We went through that. It's considered to be part of development, meaning it's not like an extra thing. It's actually especially if you do red light, green light programming, it's part of development. It forces the developer to concentrate the code she will develop. It makes you make a test. It always guarantees your code has a test because you can't write code without a test. Um, uh, um, the unit tests have fewer dependencies, uh, so it's easy to maintain, right? If you write the other tests, then every time you change something on the screen, you might have to rewrite 10 tests, right? A unit test, and generally, you don't have to change unless you change that one method or that one object. Unit tests give a very quick feedback. Unit testing increases the confidence in code. Make changes. You automate a unit test into continuous integration. Automate are simple to integrate into development pipeline. I shouldn't say simple to integrate or simple to be run by a development pipeline, right? So every time you check in code, theoretically it could run. Then we spoke about this, we all went through. This is system unit testing, component testing, system testing, release testing, user testing, partition testing. We went through that. Guideline-based testing. We went through that. Um, this is an example of partition testing. Um, this is um, it's basically what we said. We really went through all that. Okay, so this is chapter, I mean, which folder is this from? 22. Let's go to 20. writing testable code. So, um, this is basically uh, uh, the idea is number one. Oh, so you would have to look at okay. So basically, the idea is number one, you should. I think I have a better. Number one, you should allow access to code, right? We have seams, so it's easy to test uh, little parts of the code. So you shouldn't like jam code together because then it's hard to test different parts independently. Dependency injection means that when you test code, you should be able to just test that code without all the dependencies of that code, right? Like in our example, we tested the thing that turns on off the light, right? We were able to inject to test it with a fake light switch. Okay, and also we were able to not rely on the current time on the time that's passed in because we would control what time was passed in, right? So it wouldn't be it wouldn't be what's the word? It wouldn't be random. The law of Demeter means that you shouldn't have methods that are kind of messed up, where the you pass in a parameter, but the code that's really being used is a grandchild of the one that's passed in. So basically, the rule is basically you should just have one dot within the code. We'll go through that, and then and then the other idea is idempotent, which means that code should be able to be, the unit test should always be able to be run over and over again. It shouldn't fail if you run it twice, for example, right? She'll run it 20 times, 100 times, 1,000 times without getting a different result, okay? Um, and then we get to chapter 23, and chapter 23 is, I mean, class 23. There is no class 23. I thought there was. There's a 24. Here we are. And this is basically, let's see what I wrote here. Same deck. Okay, so basically I go into I'll go into here for the rest. But basically this is where we ended up. Over here. Is that okay. Um, our main code is over here, right? This is our main code called check light, and we're passing in, first of all, we're returning a value. Number two, we're passing in all the dependencies, meaning the time we're passing in and the object we're passing in. So when we call it from main, we're calculating the hour and we're creating a new light bulb outside the test, right? Outside this method. And then over here, when we write the test, we we pass in a different object. So over here, we're hard coding that time, so we know we know we could predict what the result's going to be because we're passing in the time, and we're passing in a pretend light bulb, so it won't make it hard to test, right? Because the only thing we're really interested in is will it turn the light on and off depending on this parameter, right? Everything else is not important for this method, right? This method doesn't care about the light bulb or the what the current time is. It just the only thing it cares about is what to do for whatever time is passed in. So this is very good code, And then the other thing I did over here was I showed you the law of Demeter over here, where this is bad. So over here, it's bad because we're passing in object A, but we're calling the method that belongs to C, right? So that's very bad because it looks like we're doing something with A, but really we're doing something with C, right? Not saying the code won't work, it's just bad. But over here, this is much better, right? This is the refactored version, which works much better, where we're just passing in C and we're calling the C method, okay? So this is bad. Well, it's on my machine, so you're not going to be able to get it. Okay, so this is bad and this is good. Okay? So I think that's pretty much it. Send me email if you have any questions. Any questions now?
Will this video be on the Google Drive?
Say again?
Will this video be on the Google Drive, like the recording?
Yes, yes. It'll be there tomorrow morning, should be. If it's not, email, okay?
Okay.
Okay, see you.
How many questions are going to be on this next exam?
It's nearly identical to the midterm.
Got it. Okay.
Okay. Okay, I'll see you. Bye.
All right, thank you so much,
Thank you. Have a
Professor.
great night.
Okay, you too. Have a good night. Okay, bye.
Professor.